716 is using synthetic division to find the zeros. So if f of x equals this polynomial and x plus 7 is a factor of f of x, then find all the zeros algebraically. And so we want to think about zeros are found by factoring. Remember, we factored quadratics over and over and over. It still shows up and stuff. We also learned how to factor a polynomial that had 4 terms, and we did it by grouping, right? We did these 2 terms. What can we take out? We could take out an x squared. But look at these 2 terms. They don't have an x in common. They can't divide out of 3. There's no GCF, so I couldn't factor by grouping, so I would be stuck. But because they're telling me this info right here, that's going to help me out. And so what I want to do is use long division, or not long, synthetic division, because it's going to be a lot faster than long division. And I'm going to divide this and see what's left over. So I've got my coefficients of 1, 3, negative 25, and 21. I'm going to divide by negative 7. And you better end up with the remainder of 0. That's why it's a factor. I'm going to write what this polynomial really is now. This is x squared minus 4x plus 3. Okay, so I'm going to now write what the function is. The function factored is, I know I had an x plus 7. They told me that in the problem. And then I know when I factor out an x plus 7, I'm left with the polynomial x squared minus 4x plus 3. Does that hopefully make sense? If I were to FOIL or multiply, distribute, whatever this, it would end up back to this. I definitely don't want to do that. So then my job is to continue factoring this. This is now something I can factor because it's a quadratic. And so you got to think about what multiplies to make 3 that adds to make negative 4. That would be negative 3 and negative 1. So now this polynomial is fully factored, and so you just have to find the zeros from the factors. So this would be negative 7, this would be 3, and this would be 1. Those are the x-intercepts or the roots or the zeros. All right, number 2. Worded differently, it says if f of x is this and f of negative 2 is 0, then find all the zeros of f of x algebraically. So what does this mean? This means that an answer of negative 2 is a factor, or it works because there's no remainder. And so that factor must have been x plus 2 to get this answer of x is negative 2. So remember, they're always opposite. So this is a factor. So I'm going to go ahead and set this up and do synthetic division again. Always make sure everything's here so you don't need any zeros for placeholders. Of 3, 4, negative 9, negative 10. Dividing by negative 2. Oh, yeah. Okay. I got confused and thought I was doing long division for a minute. And you better end up with 0. Okay, so off to the side, I'm going to write what this function is. So first thing is factored out is the x plus 2 that we got from the problem. And then this becomes a 3x squared minus 2x minus 5. And so our job is to factor this quadratic now. It's just you're breaking it up into pieces. You're going to have to do slide and divide. So that's negative 15. That would be negative 5 and positive 3, and then divide by 3. So all factored out is x plus 2 times, slide this up, 3x minus 5, you can't have fractions in your factors, and x plus 1. But then the solutions, or the zeros, are negative 2, positive 5/3, and negative 1. And the last one, if this function f of x is this and f of 6 equals 0, find all the zeros algebraically. And so this again tells you that x minus 6 is a factor. So go ahead and do your synthetic division. And you should end up with this, which then means it's 2x squared minus 4x plus 4. My factor that I got from the problem is x minus 6. So now I would have to factor this I'm going to take out a 2. I'm not going to float that in the front. That'd be x squared minus 2x plus 2. And then I'd still have to factor this. My question to you, is there any two numbers that are going to multiply to make 2 and add to make negative 2? Because my options are either 1 and 2, which would add to make 3, or negative 1 and negative 2, which add to make negative 3. No. So how else did we learn to solve a quadratic if factoring doesn't work? Quadratic formula. X is equal to negative b, so that means the opposite of that, plus or minus the square root of b squared, negative 2 squared would be 4 minus 4 times a times c all over 2a. Boom, 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 boom. So that would be 4 minus 8, right? 4 times 2 times 1, 8 over 2. That is really 2 plus or minus, that'd be square root of negative 4. So what am I going to end up with? Imaginary numbers. That would be a 2i over 2. Simplify, divide by 2, so that would be a 1 plus or minus 1i or 1 or just I. And so it's that. So we didn't get to factor, but we had to solve by quadratic formula. So our answers, or our zeros, is the 6, that's positive, and the 1 plus or minus I, because that gave us 1, 2, 3 answers, which matches the highest degree of our polynomial, which is what happens when you find the roots. So hopefully that makes sense. You're using synthetic division to kind of break your polynomial down into the chunks to make it 1 degree less, so at least it's a quadratic that we can hopefully factor, and if not factor, do quadratic formula.